Good morning, dear friends. Welcome to W Knowledge Channel. I am Dr. Linus, Associate Professor and HOD of Electrical Engineering Department at Sanjay Godavat University, Kolhapur. In this power electronics simulation, power electronics converter simulation series, today I am going to explain about buck converter. Before going to this video, I would request all the audience to subscribe this channel and press the right side bell button so that forthcoming lectures also you can easily trace out and understand well. Then another one, please revise this boost converter operation. How will it work? Whenever the switch is on, therefore the output voltage, that inductor will store energy and the output voltage will be zero. Then whenever the switch is off, there is having the stored energy in the inductor and the input voltage will appear across this output voltage. That is what we have a output voltage higher than the input voltage. Output voltage formula V naught is equal to Vs divided by 1 minus del. Whenever the duty cycle is 0, output voltage is equal to input voltage. Whenever the duty cycle is 0.5, output voltage is equal to 2 times the supply voltage. Whenever the duty cycle is 1, output voltage is equal to infinity. So there is no point in explaining that output voltage is equal to infinite. Only I will, after 0.6, output voltage will be always, it will be gradually increased. So I will explain today whenever the duty cycle is 0, what is how the output voltage will be. Whenever the duty cycle is 0.5, how the output voltage will be. Let me share my presentation, that simulation screen. I hope the screen is visible to you. So this is our boost converter. This boost converter input voltage I have given is as 220 volt. I have designed the inductance, approximate value is 5 millihenry. I have given here 5 in e power minus 3. Then this is the switch. In the switch pulse generator I have connected. In the pulse generator, the switching frequency is 5 kilohertz. Therefore, the period I have given by 1 by frequency, so that 1 by 5000. Then pulse width, it can vary from 0 to 100. Whenever the pulse width is 0 means we have the duty cycle of 0. Whenever the pulse width is 50% means duty cycle of 0.5. Whenever the pulse width is 100%, duty cycle will be 1. Then there is no changes in this phase delay and all. Then this is the diode I have connected, inductance, diode, and this is the capacitor for reducing the output voltage ripple. Then this is the resistive load. Capacitor I have chosen as 0.3 Henry and resistance I have chosen as 100 ohm. Then I hope the remaining things you know well. Each waveforms I have connected to the scope through this from go to and from blocks I have connected each one. So if you take this output voltage of the scope waveforms, in the scope waveforms, first one is the input voltage and switching pulse, switching current and inductor current, load current and load voltage. Let me run this simulation one time. See here, I am going to give this pulse width is 0. So pulse width percentage 0 means duty cycle is 0. If we give duty cycle is 0, there is no point in the switching. This switch, this is like one open circuit. The switch is in open circuit. But in the simulation, if you press pulse is equal to 0, we will not run the simulation properly. So I am giving pulse width is around 0.001. It is non-zero value. That's all. 0.001. So it is always the switch is open. So what happens? This voltage and inductor, what it will do? Inductor initially voltage will be high, then it will reaches the maximum value. After that, what happens? Voltage will come down to 0 and the current will be the maximum value. So it is like a current source, short circuit. So this voltage will appear across this diode. That's all. Appear across this diode. Let us see, so that we are getting this output voltage is equal to input voltage of 220 volt. So let me run this simulation. I will explain to you one by one how we are getting this simulation as of my knowledge. I have run the simulation for 30 seconds. Now this is the input voltage I have given 220 volt, we know. Then I have run the simulation for 30 seconds to get this stable steady state output. So if you take this here, if you take this initially here on switch current, switch current will be there due to that small, we are giving small duty cycle, no, due to that we are getting some switching current, but this on time of the switching is also very less, on time is very less, it is more or less switching current is zero, switching current is zero. But what happens, see this inductor current will gradually, it will increase. Why this increasing inductor current? Since this is the voltage across the capacitor, it will increase and it will reaches here the steady state value. Till the inductor current, current will flows through here and it will, since till this, what will happen? Inductor initially, it will, the voltage across the inductor will be zero. Voltage across the inductor will be zero. This current is maximum. Voltage across the inductor will be maximum and the current is equal to zero. So this is that position. Current is equal to zero and voltage across this inductor will be maximum. Then as I am giving continuous voltage, the current is maximum, it is increasing, right? This current is increasing in this maximum value. That time it will be act as a current source. It will be act as a current source. So that what happened, the voltage across this capacitor, the voltage across the capacitor is same as the voltage across this voltage across this load, right? This voltage across the load, till this we have the current flow. Since the diode, here we have one diode, right? This diode will be forward bias till there. One particular time, what happen? This voltage will be same as this voltage, right? This in this position, voltage will be. You can see this waveform. You can easily understand. It is voltage across the capacitor gradually increase. So till that there is having a flow of current. After that, this diode will be reverse bias. Therefore, the load current will be approximately zero. But at the same time, after some time, this load current will be settled, load voltage will be settled down to 220 volt. We already know now the duty cycle is zero, therefore the output voltage is same as this input voltage. So that is why there is an increase in spike in this initial value due to the effect of inductor and capacitor. Let me show this very clearly. Due to this effect of capacitor and inductor, so diode will be forward bias so that it will be continuously flow. Once this voltage reaches the steady state value, therefore there is no voltage drop, there is no current flow in this inductor. So now let me show this duty cycle of 0.5, that means 50 percentage. That is the interesting concept, you can explain, you can understand well. See, output or input voltage is equal to 220 volt. Then initially this, it will be switch on and switch off. Due to that, will be on with respect to the wave shape of this initial transition, initial this current, right? Due to the forward bias of diode and capacitor voltage is zero, it will be, diode will be forward bias, therefore current will be increased. Moreover, inductor current will be also increased. Then inductor current, once it reaches, then so the capacitor, once this capacitor voltage reaches this maximum value, this inductor current will be zero. Then this is a transient time, it will happen. Let me show this this steady state time. In the steady state time, if you see here, see on time, off time, right? This is the on time and off time. So let me here, this previous case, if you see this waveform, 50% switch will be on and 50%, see 50% switch will be on and 50% switch will be off. Then let me show the switch current. The switch current also, if you see and zoom it, you will come to know switch current will gradually increase. Why this on time switch current will gradually increase? Due to the current flowing current in the inductance effect. Inductance will current will also in the during the when the switch is on, inductor current is same as that switch current, right? So there it will be gradually increase. Then we have that inductor current, you can draw separately. We can see here inductor current. See, when the switch is on, inductor current will increase. When the switch is off, inductor will release the energy. That is why current will come down, right? Then here the load voltage divided by current. So we have 100 ohms resistance, so that we are getting this output voltage approximately 440 volt. I already told you input is 220, duty cycle is 0.5, therefore output voltage is 440. Then we have this load voltage is reflecting the same. How it is reflecting? We have the voltage of at 440 volt, 440 divided by 100, you will get 4.4 amps. So this is the output of this output voltage of this buck boost converter, and when during the duty cycle is 0° and duty 0% and duty cycle is 50%. I hope this concept is understandable. If you have any doubts, kindly comment on it. I will explain it. Moreover, that under this electrical vehicle playlist, already boost converter closed loop also I have done. If you are interested, just to go through that also. I hope these portions are understandable, and the people who like this channel, kindly subscribe it and give the likes or whatever you want, and give the comments for the betterment of this channel. Wish you all the best. Thank you.